Hello all, this is Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. Okay, we are in the chapter of limits and we have uploaded so many topics already in the playlist of limits. You can go and check it. And in today's video, we are going to discuss about limits at infinity. So how are we going to solve the problems? How do we find the limiting value of a function when its input x approaches plus infinity or minus infinity? So these kind of questions will be solved. Okay, now so these topics are very important. So listen carefully and they are easy also. We can easily answer them. First of all, let us look at the small concept that we are going to use in all questions. So what is it? So when x approaches plus infinity or minus infinity, it can be plus infinity or minus infinity, then 1 by x approaches 0. Correct or not? Particularly to say when x approaches plus infinity, 1 by x approaches 0 from the right side, 0 plus. And when x approaches minus infinity, 1 by x approaches 0 from the left side. So if you want to know exactly when x approaches plus infinity, 1 by x approaches 0 from the right side, and when x approaches minus infinity, 1 by x approaches 0 from the left side. Okay, now just remember this. Whatever, when x approaches plus infinity or minus infinity, I'll just simply write that 1 by x approaches 0. Okay, now next, if 1 by x approaches 0, then 1 by x square, 1 by x cube, 1 by x power 4 and all these approaches 0. So this is what I'm going to use while solving the problems. Okay, now first of all, let us look at basic questions on this particular concept. So in the first few questions, we will take rational functions. Okay, now where numerator is a polynomial and denominator is also a polynomial, and when x is approaching infinity. Okay, we'll see how to solve these kind of questions. These are very easy questions. First of all, I'll tell you how to solve these questions. Then I'll tell you how to write the answer directly using some shortcut. Okay, so first of all, what is the process? How to solve these questions? Basically, when you directly substitute x as infinity, what do we get? 4 into infinity minus 3 into infinity plus 1. The numerator looks like infinity. The numerator is approaching infinity. And similarly, when you substitute x as infinity in the denominator, 3 into infinity power 4 minus 3 into infinity cube plus 2. The denominator also approaches infinity itself. So this particular question is in which indeterminate form? So it is in the form of infinity by infinity. So generally, so in the problems of limits at infinity, okay, now so the given function will be in the form of infinity by infinity. Okay, so anyhow, let us see how to solve this particular question. Very simple. What is the highest power of x in the numerator and denominator? X power 4, correct or not? So divide the numerator and denominator with highest power of x. So limit x approaches infinity, 4x cube divided by x power 4 minus 3x square divided by x power 4 plus 1 divided by x power 4 whole divided by 3x power 4 divided by x power 4 minus 3x cube divided by x power 4 plus 2 divided by x power 4. So we just divided the numerator and denominator with highest power of x, which is x power 4. Correct or not? Next, if you simplify this, limit when x approaches infinity, as I told you, 1 by x approaches 0. Correct or not? So this becomes what? 4 by x minus 3 divided by x square plus 1 by x power 4 whole divided by, here x power 4 and x power 4 cancels, will get 3 minus 3 by x plus 2 by x power 4. As we have discussed at the starting of the video, when x approaches infinity, 1 by x, 1 by x square, 1 by x cube, 1 by x power 4, all these approaches 0 only, right? So it is equal to, this value is 0, this is also 0, plus that is also 0, whole divided by 3 minus 0 plus 0. So the answer is 0. So is it necessary to solve this entire steps? Means not needed. So how can we write the answer directly without solving all these questions? Means very simple. The shortcut is simple. So it should be a rational function where numerator is a polynomial and denominator is a polynomial. Okay. If degree of numerator is less than degree of denominator, then very simple, limit x approaches infinity, f of x by g of x will be equal to 0 over. In this case, The degree of the numerator is 3, the degree of denominator is 4, the degree of numerator is less than degree of denominator, correct or not? Then what is the answer? Directly we can write the answer as 0, because the degree of numerator is lesser than degree of denominator. So we will see other questions where the degree of numerator is more than degree of denominator, okay na? And also when the degree of numerator is equal to degree of denominator. So I hope you understood how to answer this question directly. We will go for the next question. Here is our second question. So in this case, the degree of numerator is 5 and the degree of denominator is 2. The degree of numerator is more than degree of denominator. Okay, now, but the method of solving is same in second example also. What do we do, dear students? Divide the numerator and denominator with the highest power of x. And the highest power of x is x power 5. So divide the numerator and denominator with x power 5. So what do we get? Limit x approaches infinity, 5x power 5 by x power 5 minus 3x cube by x power 5, and then minus 2x by x power 5 whole divided by 4x square by x power 5 minus 2x by x power 5 plus 1 by x power 5. Okay now, so in that case, limit x approaches infinity, here you'll get 5 minus 3 by x square minus 2 by x power 4 divided by 4 by x cube minus 2 by x power 4 plus 1 by x power 5. So obviously when x approaches infinity, 1 by x and other powers of 1 by x approach 0, correct or not? So this will be 0, 0, 0, 0, 0. So what are we going to get? 5 minus 0 by 0 minus 0 plus 0. So the answer is looking like 5 by 0, correct or not? So the answer is going towards plus infinity. But understand one thing, you can say, sir, when the denominator is 0, you should write the answer as not defined. Na? Why are you writing infinity? Means you already, I have told in many of the questions, here 0 is not exactly 0, it is 0.0000 something. Okay, now. So however, I got the answer as plus infinity. But why did I get the answer as plus infinity? Because this number 5 is positive. What if the same question is like this? Minus 5x power 5. Then here we could have got minus. Here we could have got minus, here we could have got minus, then minus 5 by positive 0 will be minus infinity. So who will decide whether the answer is plus infinity or minus infinity? The coefficient of highest power of x. He will decide whether the answer is plus infinity or minus infinity. If the coefficient of highest power of x is positive, I will get plus infinity. If the coefficient is negative, I'll get minus infinity, but only in these models. So what is the shortcut to solve this particular question, dear students? If degree of numerator is greater than degree of denominator, then the answer will be what? Plus infinity or minus infinity. I'll get plus infinity if the coefficient of highest power of x is positive. And I will get minus infinity if the coefficient of highest power of x is negative. Correct or not? So we'll look at the third model where the degree of numerator and denominator is same. So in our third question, the degree of numerator is 3 and the degree of denominator is 3. So degree of numerator and denominator are same. Let us see what happens in this question if we go with normal method. So as usual, we will divide the numerator and denominator with highest power of x, and the highest power of x is x cube. So if that is the case, if I divide the numerator and denominator with x cube, I am writing this directly. I hope you will understand. 3x cube by x cube will be 3 minus 4x square by x cube will be 4 by x. Please think how. Plus 1 divided by x cube is 1 divided by x cube only. Next, 2x cube by x cube will be 2. 4x by x cube will be 4 by x square minus 3 by x cube. And we know that when x approaches infinity, 1 by x square and 1 by x cube, all these approaches 0. Correct or not? If that is the case, 3 minus 0 plus 0 divided by 2 plus 0 minus 0, and the answer will be what? 3 by 2. So what is the shortcut, dear students? If degree of numerator is equal to degree of denominator, I hope you got the clue now. So what is the shortcut? Very simple. If the degree of numerator is equal to degree of denominator, Like in this case, degree of numerator is 3, the degree of denominator is 3. In this case, what is the answer? Very easy. The answer is equal to coefficient of highest power of x in the numerator divided by coefficient of highest power of x in the denominator. So here the coefficient of highest power of x is 3 divided by coefficient of highest power of x is 2. So the answer will be what? 3 by 2. So directly we can write this. Now let us generalize our result. Okay, we have L. L is equal to what? A rational function where numerator is a polynomial of degree m and the denominator is a polynomial of degree n. So there are three possibilities, correct or not? L can be any of these answers. So L will be equal to. So what will be the value of this limit when x approaches infinity? Remember, limit x approaches infinity, this L will be equal to what? The answer will be 0. When is answer 0? If the degree of numerator is less than degree of denominator. That means when m is less than n. Next, the answer will be plus infinity. When the answer is plus infinity, if the degree of numerator is more than degree of the denominator, and at the same time, who is the coefficient of x power m here? Am. If am is positive, this is important. If am is positive, you will get plus infinity, and in the same case, when the degree of numerator is more than degree of denominator, okay na? And if am is negative, then the answer will be minus infinity. So the answer will be plus infinity if am is positive, the answer is minus infinity if am is negative, okay na? The coefficient of highest power of x. Next, the answer will be what? What if m is equal to n? M is equal to n means degree of numerator is same as degree of denominator. Then what is the answer? The answer will be am divided by bn. So there are four possible answers. The answer can be 0 or plus infinity or minus infinity, or it can be am by bn. Okay, now let us test ourselves whether we can write the answer directly or not with 4 different examples. Okay, now. So if you use the shortcut now, can you try and write the answers of all the 4 questions? Of all these 4 questions, just pause the video. First you answer them, then I will say what are the answers. Okay, let us check. So I hope you have tried it. Now the answer is very simple. The degree of numerator is same as the degree of denominator. Na? Then the answer will be coefficient of highest power of x in the numerator by coefficient of highest power of x in the denominator. So the answer is 3 by minus 5, which is minus 3 by 5. So I hope you got the answer. Next, in fifth exam, let us see the fifth question now. In this case, the coefficient of, the degree of numerator is more than degree of denominator, right? The answer is what is it, plus infinity or minus infinity? The answer is what? Minus infinity, because the highest power of x coefficient is negative. So the answer is minus infinity. I hope you got the same answer. Next, please observe properly. What is the degree of numerator? 3. The degree of denominator? 5. In that case, what is the answer? The answer is 0, because the degree of numerator is less than degree of denominator. And finally, in the 7th example, if you have written the answer as infinity, let us be careful. That's where we have to be careful, because x is not approaching plus infinity, but x is approaching minus infinity. So while solving this particular questions, while solving the questions when x approaches minus infinity, let us follow one model to make sure that we always get correct answer. So what I will do is, since x is approaching minus infinity, I'll let x is equal to minus y. Or let us assume that y is equal to minus x, or x is equal to minus y, no problem. So if x is approaching minus infinity, x means minus y only, na? X means minus y approaches minus infinity, so automatically y approaches infinity. Y approaches plus infinity, and in question also, instead of x, what we will substitute? Minus y. So the entire question is changed as what? So the entire question is changed as limit, instead of x approaches minus infinity, I will write y approaches infinity 4 into, instead of x we are going to substitute minus y everywhere in the numerator and also in the denominator. Instead of x we are substituting minus y to avoid confusions while getting the answers. Okay na? So limit y approaches plus infinity, this is minus 4y cube minus square will be plus, plus into minus minus, 6 into y square whole divided by minus 9y plus 2 into minus y whole square is y square. Now you can answer the question just like the previous question. The degree, but the numerator is a polynomial in y, the denominator is also a polynomial in y. So the degree of numerator is greater than degree of denominator. For that reason the answer will be plus infinity or minus infinity. So how do we decide that? So the coefficient of the highest power of y is negative na, so the answer will be minus infinity. Okay na? So if you have got plus infinity as answer in 7th question, be careful. That's why we are saying these kind of changes are always useful to give us exact answers. Okay now I will use this method in many upcoming questions whenever x is approaching minus infinity to avoid the confusions. Okay, now let us see some basic questions. Let us solve as many questions as possible on limits at infinity. Here is a question: limit x approaches infinity, numerator by denominator, and the moment students see this question, directly they'll start rationalizing the denominator. But please wait, we should not hurry up. If you think peacefully, okay na, this is a question. What kind of question it is? A question, what is it? Limits at infinity. When here x is approaching 0 na, there is not x is approaching some kind of finite number or something. So how I'm going to solve this question, that's important. Observe carefully. Limits at infinity, right? So what I'm going to do is, limit x approaches infinity, take numerator x common, x into 1. In denominator also, in each term we have to take x common. How do we take x common? Please observe. Inside this term, I'll take x square outside the root. When x square comes outside the root, it takes the root. X square comes outside, it becomes root x square. Root x square is x because x is positive. If x is negative, when x square comes outside, we should write minus x. Keep this in mind. Okay, fine. X square comes outside. Okay, na? And it becomes x. So square root of x square went outside na. So here m is remaining. But here x square is not there. But still I took x square common. Then n becomes n by x square. Same story, minus. In these two terms also I will take x square common outside. When x square comes outside the root, it becomes x into square root of p plus q by x square. Now here and here we can take x common and I can cancel with this x. Limit x approaches infinity, x into 1 divided by, when I take x common, x into under root m plus n by x square minus under root p plus q by x square. Okay, I took x common na, x ones are and x ones are. So x and x gets cancelled. Now when x approaches infinity, 1 by x approaches 0. 1 by x and all the powers of 1 by x approaches 0 only, right? Therefore, look at this, n by x square will become 0. Q by x square also will become 0. Now what happens to the answer? The numerator is 1 divided by root of m plus 0, which is m, minus root of p plus 0, which is p. This is the answer. 1 by root of m minus root of p. 1 by root m minus root p. So directly when we see the function, we should not do rationalization. Please understand what kind of question it is. You can try using rationalization method, that's up to you, and let me know what answer you have got. Okay na? Fine, we'll go with next question. Now here is our next question, which contains 4th root of, 5th root of, cube root of and all. As I told you in the previous question, let us make it simple. What I am going to do is, listen, this point is very important. Inside the 4th root, I will take x power 4 common. Are you understanding? Inside the 5th root, don't take x cube common. Inside the 5th root, in the two terms, I will take x power 5 common. Inside the cube root, what I will take common? X cube common. And inside the 4th root, I will take what common? X power 4 common. Is it clear, dear students? Once again, what? Okay na? So 4th root of, in these two terms, I will take x power 4 common. So here 1 plus 1 by x power 4. And next, what students will do inside the 5th root here? Generally, they will take x cube common, but I am not taking x cube common. This function is inside the 5th root na. I will take x power 5 common. I'll take x power 5 common inside the fifth root. When I take x power 5 common, this becomes what? When I take x power 5 common, it becomes 1 by x square. Plus I took x power 5 common, so it becomes 1 by x power 5. So verify whether if I multiply this and this, I'll get this or not. Next, dear students, inside the cube root, I will take x cube common in these two. So x cube into 1 plus 1 by x cube minus inside the fourth root, what I will take common? X power 4 common. In these two terms, I will take x power 4 common. So x power 4, I took x power 4 common here, it becomes 1 by x. I took x power 4 common here, I will get 1 by x power 4. Please think about it. These are very easy. Why should I do like that? Means limit x approaches infinity. Now fourth root can be separated for these two under the product. Fourth root of x power 4 is x into fourth root of this. Fourth root of 1 plus 1 by x power 4 minus fifth root can be separated for these two. So fifth root of x power 5. Fifth root of x power 5 is x into fifth root of 1 by x square plus 1 by x power 5 whole divided by, so I'll write divided by like this. Cube root will be separated for these two terms now. So let me write, okay, cube root of x will be what? X. Cube root of x cube is x into cube root of this. Cube root of 1 plus 1 by x cube and then minus fourth root of x power 4 is x into fourth root of this. Fourth root of 1 by x minus 1 by x power 4. Correct or not? Now dear students, as x approaches infinity, 1 by x approaches 0. But before that, in the numerator I can take x common. In the denominator also I can take x common. Okay. So in the numerator I can take x common. X into fourth root of 1 plus 1 by x power 4 minus fifth root of 1 by x square plus 1 by x cube. Similarly, in the denominator also, in these two terms, I can take x common. Cube root of 1 plus 1 by x cube minus fourth root of 1 by x minus 1 by x power 4. Obviously, x and x get cancelled where limit x approaches infinity. And since x approaches infinity, 1 by x approaches 0 only. Na? So, fourth root of 1 plus 0 minus fifth root of 0 plus 0. Please observe. Divided by cube root of 1 plus 0 minus fourth root of 0 minus 0. So what is the final answer, dear students? Fourth root of 1 will be 1 minus fifth root of 0 is 0. Fourth root, cube root of 1 will be 1 minus fourth root of 0 is 0. The answer is 1. The starting step is very, very important. What to take common. Okay, na? So I hope you understood this. We'll go for the next question. So here is our next question. When limit x approaches infinity, we are supposed to find the value of this function. If I directly substitute x as infinity, the function will be in the form of infinity by infinity. Correct or not? See how I am solving this particular question. So what I am doing is, obviously, I'll divide the numerator and the denominator by root x. Okay, na? So then what happens? Limit x approaches infinity, root x by root x is 1. And the denominator is also divided with what? The denominator is also divided with root x. Correct? Now root of divided by root of means single root is enough now. So single root of what will you get? Single root of numerator by denominator. I divided the numerator and denominator with root x. Then what happens? X is a common denominator, I can separate it. So limit x approaches infinity, 1 divided by square root of x by x is 1 plus this x is a denominator for this function also, right? So square root of x plus root x divided by x. And dear students, this square root is only for the numerator. I want this x to go inside the square root. Then what happens? Then if x goes inside the root, then x becomes x square. Okay, now if x goes inside the cube root, it becomes x cube. Here it went inside the square root. Now again x square is a common denominator for these two, you separate it. what you will get? Limit x approaches infinity, 1 by root of 1 plus root of x by x square will be 1 by x plus root x by x square. Root x by x square. Okay, now again take this x square inside the square root. Limit x approaches infinity, 1 divided by under root 1 plus under root 1 by x plus, when x square goes inside the square root, the numerator x as it is, x square went inside the square root, it becomes x power 4. Okay, now and you can cancel x 1s are and the x cube. Next we can apply what? When x approaches infinity, 1 by x approaches 0. Na? So what is our answer? The answer is 1 divided by square root of 1 plus square root of 1 by x is 0 plus square root of 1 by x cube is also 0. So what is our answer, dear students? The answer will be 1 divided by 1, which is equal to 1. Okay, 11 and 12 are same models which contains modulus function. Okay, now let us see how to answer these questions. Now when x approaches infinity, obviously x is a positive number, right? Then mod x will be taken as plus x, and here x is approaching minus infinity means x is a negative number, right? Obviously, so mod x will be taken as minus x. You should have known the definitions of mod functions. Okay, anyhow, now the question becomes very simple. Limit x approaches infinity, 2x plus mod x is taken as x, so 3x divided by 5x minus x. So limit x approaches infinity, 2x plus 3x is 5x divided by 4x, x and x gets cancelled. The answer is 5 by 4. Okay, and in this case we are going to take mod x as minus x. So limit x approaches minus infinity, the numerator 4 into minus x minus 7x by 8x plus 3 into minus x. So if that is the case, the numerator will become minus 11x and the denominator will become 5x, and x and x gets cancelled, obviously giving you minus 11 by 5 as the answer. Are you understanding this? How did we solve this question? When x is approaching plus infinity, x is a positive number, we will take mod x as x. And when x approaches minus infinity, x is a negative number and we will take mod x as minus x. Simple, correct? Here is our next question. Limit n approaches infinity, sigma n square whole cube divided by n into sigma n cube whole square, where obviously n is a integer. Okay, sorry, n is a natural number where n belongs to capital N. Okay, na n is approaching infinity and n is a natural number. So you should have known what is the meaning of sigma n square. Dear students, do you know what is the meaning of sigma n square? Sum of the squares of first n natural numbers, which means sigma n square means 1 square plus 2 square plus 3 square and so on up to n square. And what is its formula? Do you remember the formula? It is n into n plus 1 into 2n plus 1 whole divided by 6. Sigma n square is n into n plus 1 into 2n plus 1 by 6. You should have learnt in sequence and series. Similarly, we also have sigma n cube. Sigma n cube means 1 cube plus 2 cube plus 3 cube and so on up to n cube. And the formula for this is n square into n plus 1 whole square whole divided by 4. So we are going to use this and this while solving this particular question. Fine. So limit n approaches infinity. So sigma n square means obviously this n into n plus 1 into 2n plus 1 by 6. But sigma n square has whole cube na. So this entire term will get whole cube. So this becomes n cube, n plus 1 whole cube, 2n plus 1 whole cube, 6 cube divided by n into. Sigma n cube is what? Sigma n cube is n square into n plus 1 whole square by 4. But we have sigma n cube whole square na. What is sigma n cube whole square, dear students? This whole square, correct or not? You will get n power 4. This square is n power 4 into this square will be n plus 1 whole power 4 divided by this square will be 16. So sigma n cube whole square is this, substitute that here, into n power 4 into n plus 1 whole power 4 divided by 16. So let us see how to simplify it. Dear students, observe carefully. In the numerator, n cube is already there, correct or not? Here if I take n common in these two terms, it takes the power 3. So n cube into. What happened? Here and here I have taken n common, and that n will take this power 3 and becomes n cube. So this term becomes 1 plus 1 by n whole cube. What happened? I took n common na here and here. So this term becomes 1 and this term becomes 1 by n. Of course whole cube. In these two also I will take n common. In these two also I will take n common. And when n comes outside the cube, it becomes n cube into. I took n common na here and here. So 2 plus 1 by n whole cube. Whole divided by. N into n power 4 is n power 5, okay. And in these two terms, if I take n common, it takes the power 4. It becomes n power 4 into, here and here I took n common na, this becomes 1 plus this becomes 1 by n whole power 4 divided by 16. Dear students, observe the numerator. This is limit n approaches infinity. Observe the numerator. N cube into n cube into n cube is n power 9. N power 5 into n power 4 is also n power 9. So they will get cancelled. Okay, fine. As n approaches infinity, 1 by n approaches 0 na. So therefore, what do we write? 1 plus 0 whole cube. So 1 into 2 plus 0 whole cube is 8 divided by 1 plus 0 whole cube is 1. Again divided by 16. So this is equal to 8 divided by 1 by 16 or into 16. And we totally forgot by 6 cube in the numerator, right? So numerator by 6 cube means that 6 cube will come here in the denominator. Okay, 6 cube will come here in the denominator. And if you cancel 8 into 16 divided by 216. 6 cube is 216. So 8 ones are 8, 8 twos are 16, 8 sevens are 56. And the answer is what, dear students? 16 by 27. That is the answer. Okay na? So I hope you understood this. Dear students, we will look at more models on limits at infinity in next video. But before that, I'll write 2 questions. Can you try and let us know what is the answers for those questions in the comment section? I'll write 3 questions on the board. You can answer it. You can answer these 2 questions, 14 and 15, and you can let us know what are the answers in the comment sections. Okay, na? We'll see whether it is correct or not. That's it for today's video, dear students. These are the basic questions on limits at infinity. In our next video also, we'll look at more questions on limits at infinity. So what you have to observe is that in almost all these questions, the indeterminate form that we got is infinity by infinity. Okay, na? So fine. So this is Sandeep Kumar, and I hope you have really understood these problems. We'll see you in the next video.